Okay, so number 4 on chapter 6 test asked what are the 5 tests to see whether a quadrilateral is a parallelogram and what formula must you use? Number 4 was very similar to number 3. The only difference is you were to word it different. So instead of saying opposite sides are congruent, you're going to say to check or show if opposite sides are congruent. And the way you do that is by using the distance formula. Number 2 was to check if opposite sides are parallel, and this symbol is for parallel, this symbol is for congruent. The way you check if opposite sides are parallel is by using the slope formula. So if the slopes are the same, and the opposite sides also have slopes that are the same, then it is a parallelogram because opposite sides are parallel. And over here, for the parallelogram, the opposite sides have to be congruent. So if this side is congruent to this side, and this side is congruent to this side, it is a parallelogram. And you use the distance formula. If you recall, it's D equals x2 minus x1 squared plus y2 minus 1 squared. You did not have to provide the actual formula, but you had to say which formula was needed in order to perform the test. Third, you must check if diagonals bisect, and the way you do that is by using the midpoint. So, if you have a quadrilateral and the diagonals bisect each other, then it is a parallelogram. The way you check it is by using the midpoint. So, the midpoint will show you where the diagonals bisect. You check if opposite angles are congruent. So if you have a quadrilateral that has opposite angles that are congruent, it's a parallelogram. You check if a pair of sides is both congruent and parallel. So if you have a quadrilateral and you have a pair of sides that's parallel and also congruent, then you don't need to test the other pair of sides. You automatically know that it is a parallelogram if a pair of sides is both congruent and parallel. The way you test that is by using the distance and slope formula.